All right, testing, cool. All right, welcome to the second lesson for the Programming Merit Badge. Today we're going to go over a little bit of programming, but more so some different approaches to programming, and such as flowcharts and a programming technique called loops, user interface, debugging. So we'll jump right into it. So one way to help map out what your program is going to look like would be to use a flowchart. And flowcharts are visual roadmaps that help you decide where decisions need to be made, where calculation is going to be made, just the overall flow of the program. So we have a few shapes. So the oval right here, you use to start and end a program roadmap. Arrows are the paths. They just connect the nodes. Parallelograms are input and output. So when you write to a cell or read a cell, the value in there. Rectangles are a process, and then diamonds are decisions. So let's look at what that would look like all together. You have this program. Oops, recording bars on the right. So you have this. This is a roadmap for programming the drive called VBA-5. So we can see it follows the same syntax as VBA, the macros. So we write sub and then the program name, which is integer. And we can see it's an oval. So ovals start programs. I won't that go. Anyways. So we go follow the path to our first decision, which is an if statement. So this diamond represents an if statement. So if x equals 0, follow the path that says yes, then the integer value is 0. If x does not equal 0, follow the no path to this. So now we know it's not 0. So this if statement goes, is x less than 0? Well, yes, so then it's negative. But if x is not less than 0, that means it's positive. And these circles are just dummy nodes that just help you clean everything up and connect everything to the final end node. Okay. All right. So we'll get into annotation of code. Every program has a little bit different symbol for it, but it's all basically the same. So a few reasons why you should do this. If let's say I covered up, all this right here, you would not know, ang. What's ang mean? Oh, I commented the code here, input current angle. If you had ang equals 180, you go, why are we doing that? Switch angle to positive amount. Okay. So the neat thing about comments is every comment will not be processed when you run the program. So with VBA macros, it's the single quotation mark. And you can see it makes everything after that green, meaning the computer goes, I don't care whatever's after here, I'm not going to read it. So it's really for the user. If you have multiple people working on a code, if you have to come back to a code, if someone needs to go back and change something in your code, they can, a lot of times they'll need to change constants like this, where decrease angle by 5. Well, maybe they want the program to decrease angle by 10. Well, now they know where to look. And then just a different example of this in Java, it's the 2 slash marks, and then a comment. And then you can do multi-line comments, which is a dash and then an asterisk. And then you can indent multiple times before you have to close off the comment. So just a different flavor of it there. So debugging. So this is how you can slow down the program you're writing to be able to see where you might be going wrong. Let's say it's inputting a wrong value. So debugging lets you take it one line at a time versus the whole program running at once. So you can really see what, where it goes wrong. So in the VBA and the Excel VBA program, you can hit F8 and it'll highlight the lines like this, and that'll tell you where the program is in the, how far the program has been processed. We call it, usually it's called stepping through because you're taking it one step at a time. And the cool thing is, once you step past a line, if you hover over it, such as here, you can see that Sales42 equals reset chords, which doesn't mean anything to you at this point because this is a random program I snipped, but it really just allows you to see like, oh, this might be picking up the wrong value from somewhere, or oh, it's telling me positive, but it says here negative, so you have something backwards. And we'll do a project on debugging here, probably the next time. So something we talked about last time was loops. And loops are really cool. I think the example I used was a shopping list, where once you reach the bottom, it tells you go to the top and double check it. And that's really what loops are. So the few big things of loops I highlighted here, a few important parts. So this value up here is called a loop control variable because it controls how many times the loop will run. So in this example, the loop control variable equals a number that we don't have at the moment. So let's say that number is 5, because it's remit from the program. So to start a loop, you'll write do until x, the loop control variable, equals 5. And right now, it equals 0. So do until x equals 5, currently x equals 0. So it'll run through this whole program right here and get down to here, where it says, oh, x equals x plus 1, which 0 equals, or well, x equals 0 plus 1. So now x equals 1. And then when you're ready to go back to the top of the loop, you write the word loop. And so now x equals 1. So we go back to the top. Do until x equals 5. Right now, it equals 1. So user interface. So this is really important when you're writing a program, because oftentimes you're not writing it for yourself. You're writing it for someone else or a company to use, and they really need to understand what you're doing. An example of a good user interface would be probably Minecraft. That's a good one. If you go into your inventory and you've got the little picture of Steve in the corner, it's got little icons for where different armors go. All of his inventory is sorted into stacks, so it's really easy to understand where to put armor, how to sort, what's in his inventory and what's in the hotbar, because they break it up. And this is an example of a program that you have access to. So this is the calculator that adds and subtracts. And we can see first number, and then we highlight a space for it, blocked off. Second number, highlight a space for it, blocked off. And then we change, this is kind of yellow means I need you to put a number here. Blue means program would calculate this number, so to speak. All right, so we're gonna do, so these are the programs I would recommend you to try out for requirement 5C. Touch Develop and Scratch are very visual based, with the modules kind of already made and you just connect them to do what you need to do. And then Ladder Logic is a really easy to understand one because it's a program that's read like a book. So left to right, top to bottom. So that really helps bridge the gap. So I would recommend Touch Developer Scratch, but if none of those work, do Ladder Logic. And so this is programming you can do at home until I find a program that we can all use. Because I know not everybody has Excel on their computer. So now, I'll show you a simple loop. Just make sure my share is still good. All right. So I'm gonna insert a module. And we're gonna call this one sub-example. So we'll start off with x equal to 0. Practice our commenting with the single parentheses. Loop, control, variable. Now the words that start a loop are do until x equals 15. And then we want cells to equal x equals x plus 1 loop. All right, so that is a simple loop program written. And now to practice debugging, I'm going to hit F8, step through it. See, it highlights this line. Okay, so now if we hover over x, it tells us the value of x equal to 0. If we step through it again, x is equal to 0. So do until it's 15. Right now it's 0. Okay, we've stepped past this line. And you can now see over here, it wrote the value of x, which is 0. So if we go back and hit F8 through, oh look, x now equals 1 because 0 plus 1 equals 1. And so now if I just hold this down, you can see it completes the program, writes all of it there. So something that's really cool that you can do, say you want those numbers written out. If you put a plus in here under the cells and do x, now watch what happens. So if you notice, it ran the values downward instead of stacking them in the same cell. And that's because the output is, row 2, column 2, but now it's row 2 plus x. So as x increases, we change what row it's being written into. And then another cool because you need to increase the number by 1, so often we did this special little, to call it, special little function where if you type a variable and 2 plus marks, it'll automatically add 1. Or you can put 2 minus marks. And instead of writing, this full equation, you can do x plus plus, and that'll automatically add 1 to it. So if we just, just go through real quick here. Yeah, well, because VBA doesn't have that function, which is unfortunate. Because if it was red, it's telling me, an expected expression. So that's another basic example of, a quick example of how to do a loop. I think they're pretty straightforward, and you can put, whatever you want in the middle here. So for next time, try out one of these programs. The link is right here. I'll put it in the description of this video as well. And then what you have to do is create a document and write what you learned about the program. Include some pictures if you can. To create a document, you just open up this folder, you hit new in a Google Doc, and that'll create a document in here. Just name it something that's your name, requirement 5C. I'll understand what's going on. All right. Thank you for watching.